Hello everyone, let's go ahead with the second question. This is one more question from various different universities from past papers. It appeared. So what is the given thing is x raised to x into y raised to y into z raised to z is equal to c. C is nothing but the constant, such that x is equal to y is equal to z means all are equal, all these variables are equal. Then what we have to provide it, we have to prove it, del square z upon del x del y is equal to this whole term, which is minus x log ex raised to power minus 1, and it has minus sign also. Okay, so let's start with solution. So first thing, let's always start with the given thing. So given thing is here x raised to x, y raised to y, z raised to z is equal to c, where z is a function of x and y. So as we know, there are three variables, so that's the reason we can say that z is a function of x and y. So if you focus at the given function, it looks like variable to the power variable. So this is in this format. So I hope you remember, whenever variable to the power variable in this kind of situation comes, even though we used to do regular differentiation, we used to take a log of it. Directly you cannot differentiate it. So what we do it, we take its logarithm and then we try to simplify it. Here also in case of partial differentiation also, whenever you will come across variable to the raised to the power variable situation, you have to take a logarithm. यहाँ पे मैंने वही किया है. Since given function variable का power variable उस फॉर्मेट के है हिसाब से है, then I have taken the log on both the sides of the equation. So log of this one left hand side to the log and log of c, which is the right hand side of the equation. So after that we know the form rule of logarithm, which is like if there is a multiplication between the terms, so we can split it and we can write those terms in format of addition. So same thing I have done in here. There is a multiplication sign in between this x, y, z. So what I did it, I just splitted them separately along with addition sign. So each of these terms I have separated it by using the log rule and by using the addition sign. Again, we know the log rule when we have this power like log of m to the power n. So ये power यहाँ पे आ जाती है सामने n and then log m. I wrote it here, this rule. So this is simple logarithm rule which we have learned in school. So we will be applying over here. For each of this term I will be applying here. So this x will come over here at the front side, so it become x log x. This y will come here, y log y. This z will come over here, so z log z. So this become our equation 1. It's important equation for us, so I just labeled it as equation 1. So here couple of rules of logarithm we have used it. So now let's go ahead and simplify it. So we have to differentiate with respect to x, y, z, because if you look at what we have to prove it, we have to find del z upon del x, we have to find del z by del y also, and we have to find again second order derivative also. So first let's start with del z. So del z by del x. So differentiate with respect to x, I have done it here. So if you look at the function, our function is x log x plus y log y plus z log z. So here I will write it so it will be easy for you, x log x plus y log y plus z log z. So this is the given function. Now if I differentiate this with respect to x, so what will happen? By using the chain rule, this first function will be as it is, which is here, derivative of this one, partial differentiation of log x, similar it will be 1 by x, which is here, plus second function as it is, which is log x here, and differentiation of first function, which is 1. So 1 we don't write it. So now this will become, this is differentiation of this term. Y, since we are differentiating with respect to x, y's differentiation will become 0. So this complete term हो जाएगी 0, and z का differentiation with respect to x, since z is a function of x and y, so that's a reason Z's here also the chain rule we will be applying. Z will be as it is. Log z का differentiation of second term which is 1 by z plus second term as it is, differentiation of first term, z का differentiation 1 हो जाएगा. And since we are differentiating with respect to x, we have to multiply the del z upon del x. So simple chain rule I have applied over here for each of this term. For each term I have applied chain rule. So now if you see this x and x, we can cancel it out, this z and z I can cancel it out. So what I will get it here is first bracket I will get 1 plus log x, second bracket I will get 1 plus log z into del z upon del x, which is equal to 0. I will get something like this. There should be plus sign here in between. Now I want to find the value of del z by del x. So simply I will rearrange this equation. So what I can do it, I will take this box on the right hand side, right, and then so I will get something like this. And this later on I will, this is in multiplication with del z by del x, so it will go in the denominator. So I will get the equation or the value of del z by del x, which is nothing but minus 1 plus log x upon 1 plus log z. I will call it equation 2 because I will be using this value to substitute it in equation 1. So similarly we can find del z by del y. Only thing is here we differentiated with respect to x, while finding del z by del y I have to differentiate with respect to y. So only the difference will be here, I will be getting as a y, and I will call it as equation 3 because I need that value. If you look at the question, they ask us to prove second order derivative. They ask in the left hand side, so we need to differentiate one more time. So here I am differentiating del z by del y with respect to x. So I will get double differentiation. So that's why I have taken this del z by del y. I am differentiating with respect to x one more time partially. Okay, so now this value of this bracket which I have kept it from equation 3. So this is from using equation 3. I have kept it over here as it is. This whole bracket is nothing but this value of del z by del y. Now here if you look, since we are differentiating with respect to x, y will be our constant. Since this whole term became constant, I kept outside it here since it's a constant, and whatever is left that I have differentiate with respect to x. Since this 1 plus log z is in the denominator, I put it as to the power minus 1. So that is nothing but it's like we will consider it as a 1 upon x, and we know how we find the differentiation of 1 upon x is minus 1 by x square. So same thing we will do it here. This we will consider as x, 1 upon x, since the power is minus 1 means it's this whole power is in the denominator, its whole bracket is in the denominator. So it will be minus 1 upon 1 plus log z bracket square. That will be its differentiation, which I will write it here. So this constant which we kept it as it is, it's outside as it is, and the differentiation of that 1 upon that whole 1 plus log z is minus 1 by log z. It's similar to 1 upon x differentiation. Partial differentiation will be also same. Since here it is log z, we have to multiply with differentiation of log z as well. So here same thing I have done it. Here just I put it in the power for a different format. I have done it. Log z's differentiating with respect to x will be 1 by z and del z by del x because we are differentiating with respect to x. Now we have to find the value of this del square z upon del x del y. So I have kept this value over here in the above equation. From equation 2 I have kept this value. If you look here, the above equation, we have got this del z by del x, which value we already found it in previous equations. So simply I will go ahead, all these terms I will keep it as it is, only here I will keep the value of del z by del x, so that I will get the value of double differentiation. So here this value is del z by del x value is this one, which we already found in equation 2. If you have any doubt, you can go back and refer to that equation, how we get that value. So now directly I will put it over here, and then I can do it here. If you remember, in the given question they have said that x is equal to y is equal to z. So simply what I will do it here, instead of y I will keep x, instead of y and z I can substitute x, because they are saying x is equal to y equal to z. So simply wherever I see y and z, I will just go ahead and keep the x value. So if I will do this, then what I will get is 1 plus log x here, and this 1 plus log x which is already there. So in the numerator I will get 1 plus log x bracket square, and in the denominator this is 1 plus log x bracket square, and this is 1 plus log x. तो हो जाएगा 1 plus log x का cube, that I have written over here. So simply this will come up to this step. So if you look here, now this is square and this is cube. So I can cancel it and it will come to the simplified way. Now if you look at the RHS, we don't see any 1, that is given in the form of log e. So you think about it, how we can get log e. So we know that instead of 1 we can write log e. So I just introduced that log e over here, and by using the log rule I have written like this. Now here log e's value I have written as a 1. So x into log e, here instead of 1 I put it log e. Now these two logs are in addition. So instead of addition I can replace with multiplication by using the log rule. So then after this, just how I can format different way. This is in the denominator, so I just put it here in the form of numerator. So it became the power minus 1. Okay, this is how we solve the few questions which are on exam based questions. Those are important equations. Here simply we have used the log rules and differentiation and double differentiation. Hope you understood it clearly. Thank you.